Morning, everybody. Morning, trigger happy Eli. Hope you guys all had a great weekend. So J.R. Conrad, I have it saved in the right format in the editor, but I don't see it. So your current folder, MATLAB, your default current folder in MATLAB is the MATLAB folder that's automatically created in Documents. What you should do is just navigate to where that script file is. You can always run it, and a dialog box will pop up and says, hey, this script file isn't in your current folder. Do you want to add that folder to the path, which I'll talk about today, or do you want to change your folder? And you can click change your folder. That's what I do most of the time. But there's a couple ways to make it in your current folder. One, just navigate using the normal navigation tabs along the top to find that in your current folder, or to just run the script and say change folder. Try one of those, see what happens. Swiftness, we end at 10. Class technically starts at 9:10 and goes until 10 o'clock. Wait, calc class shouldn't start at 10. The normal class times have switched. It's 8, 9:10, 10:20, 11:30, etc. Is that not at normal time? Good morning, flambéed. However you'd say that. Cup of noodles. Flambéed, I'm assuming. Once again, I hope everyone had a great weekend. Let's see how many people we have here. Okay, I'm getting a 22, 23 count on my browser. So when you first open your homework file in MATLAB, the variables in the workspace. So your variables aren't going to show up in your workspace until you actually run the code. In MATLAB, when you close it, it completely deletes anything that was in the workspace. But you just rerun your code. You just rerun your code, and they'll just reappear in your workspace. Sandwich Twitch, how does binary scientific notation work? I'm still confused. So a lot of people had questions on section 1.9 and 110 in your textbook. We aren't going to get into those specifics. Those are more behind the scenes. We will talk about them more when we get to week 5, I think. when we get to comparing variables and comparing values, you don't need to know exactly how numbers are stored in binary. When you get to scientific notation, there's two pieces. It stores essentially the number, and then it stores the exponent. But you don't need to worry about that specific details. Like I said, we will get into some more information in terms of accuracy and precision when we get to comparing values. Like I said, it's week 5, I think, week 5 or 6. I can't remember anymore. We changed things around 2 years ago. So don't worry too much about that. Sarah Barrow, I couldn't find the test for the videos. So yeah, it may not have been clear. You click on the link. It says watch week 2 videos. You literally click on that link. It's a hyperlink to the test. Holly, yes, binary is just another way to store your numbers. A different base. Instead of 10, we talk in base 10, binaries in base 2. Okay, so let's go ahead and begin. So I'm going to share my screen today because I wanted to show you essentially from the start how you would go about doing things. Okay, so in week 1 on UB Learns, just a review of stuff that Sarah and Nachev mentioned. So in week 2, scripts and functions, things you should be working on. You should be working on homework 1, which we'll go over that whole process for today. For today, we are going to talk about script files specifically, which I introduced last week, but also in the videos for today. So theoretically this last weekend, if you haven't completed these, that's fine. The due date that's listed for the week 2 videos is more of a suggestion. But you should have watched these videos. So I created a YouTube playlist for them. Like I said, it was about 20-ish minutes. I'm going to try and keep it to about 20, no more than 30 minutes for the videos you're watching on Fridays. And then you will take the quiz. So if you look at this here, if there's an underline, that means that they are hyperlinks. So this is a hyperlink. When I say read chapter 2, that's a hyperlink to your textbook. When I say watch week 2 videos and take comprehension check survey, you click this and it takes you to the quiz. So the quiz looked like this. Notice it was just 4 simple questions and then a question that I asked if you were having any difficulties. A lot of you guys talked about difficulties with understanding function calls. We will get to functions on Wednesday, but that's great. I'm glad you guys are thinking about it. But we will get to function calls on Wednesday. So it's a suggestion. It's more to show you that there's something to do. But like I said, if some students aren't going to be watching lectures live, some students are going to be watching them later on, although I don't know why you wouldn't join this awesome chat room that we have live. So some students, if you're watching the lecture videos later on, just given time constraints and stuff, you guys can manage your own time. So that 9 o'clock is more just to show you that there's something that should be done before lecture. Also, several people noticed that you can take it multiple times. And they're just simple quizzes. They're going to be a little bit different than what you get in Zybooks. It's just a different way for approaching problems, approaching comprehension. So feel free to take it as many times as you want. This last question, what has been challenging thus far? That is not necessarily on the videos themselves. Given the fact that that's new material, this is literally anything. So the week before, just something that I know that might require some more clarification, maybe some more focus. So just let me know. It's a way to give me some feedback each week, given the fact that I can't see all of your guys' faces. Although I get way more feedback with this chat than I've ever gotten in person. So this is great. Okay, so guys, make sure you guys are doing that. I'll leave that. When it says attend lecture live stream, this is a link to Twitch. Like I said, we will go over script files today, function files on Wednesday. Do homework 2. This is a link to where you will submit the homework. Here's a link to the homework document, just because of the way we have it. The homework documents are going to be non-downloadable and hyperlinked. Sorry. Just worrying about people posting things on Chegg and ruining it for everybody. Another thing is using MATLAB Grader. I'll talk about that today. You guys all should have gotten an email on MATLAB Grader this morning. Go find that email and sign up for MATLAB Grader. Do it now, okay? Do it now. And then attend office hours. So office hours begin this week. This PDF here shows all of the office hours so you guys can see most hours are covered by someone. It's one single link for all of the in-person office hours, and then you guys all have the link to the Discord server as well. It is very colorful. Yes, Dr. Ali did all the colors. So I have office hours directly after class on Zoom. And so it's just one link for everybody. And you can see that there's most of the time between the hours of 9 and 6, you should be able to get some help at this link. I don't know how each of the office hours are going to be run. Sometimes there's just going to, I mean, I'm assuming for most TAs, most instructors, you will be put into a waiting room and you will be let in one at a time. I am not planning on running our office hours that way. My philosophy for office hours is help as many people as possible. But once again, you shouldn't be sharing your screen, your code with other students. So you might have to be a little bit more creative on how you are going to talk about your code. But anyway, okay, so office hours are there, all the links on UB Learns, all those resources. Okay, so I want to focus on script files today in the context of putting together your homework. So I'm going to go ahead and go back to week 1. In week 1, you notice there's your homework link, and your homework looks like this. So there's a lot here on this front page. It's really just stating you're doing your homework in MATLAB. You have 2 separate files that you're going to write. And then tells you how those files should be named. Okay, so first thing you should do is go to your file, whatever, choose a folder, create a folder somewhere on your computer, ideally on some cloud-based service. If you have Drive, if you have Box, if you have OneDrive, whatever you use to store your files, create a folder there. Okay, so here I'm just going to be in my documents just as a reference, and I'm going to create an EAS 230 folder. Okay, so now I know I have a folder. Then go to MATLAB, and you can navigate to that folder. So once again, you can use these tabs up here to navigate. So here I'm in the C drive, users, my username, Emily Hammond, documents, and then here I'm in my EAS 230 folder. Okay, so navigate to where that folder is located. And then you want to go ahead and create a new file. So we're going to write script files for this homework. So you say new script. It opens up your editor. You can change the layout of your desktop however you want it to look. I have mine laid out like this. Yours probably looks a little different. That's totally fine. I've got my workspace down here that shows all my variables. I've got my current folder that shows my files, my editor, and my command window. You're not required to attend office hours. That's just as a reference if you need help, attend office hours. Okay, so I've opened up a new file. It opens up my editor. The first thing you should really do is put some comments at the top. Remember, comments give context to our code. So typically my comments include the author, the date for this class, spring 2021 works just fine. And then typically I have some purpose listed there. Some broad-based, what is the goal of this script file? Okay, so we've got our comments at the top. We've created our script file. Let's go ahead and save it. Okay, so I'm gonna click save. Note it's untitled, so it's automatically pops up the dialog box that says, hey, where do you want to save this? Save it in that folder you just created. And then if it's for your homework, there's a specific way you need to save your files. It's homework 1, problem 1, _ followed by your UBIT name. So mine is EH32. It's that first part of your email. And then .m. This is how you should be saving your files. Homework 1, problem 1, underscore eh32.m. Click save. Notice that file shows up in your current folder. Nicely saved. That's the first thing you should do to start your homework. Let's go back to the document, which is here. It says only files with .m extensions will be accepted. Every file has an extension type. A Word doc is .docx, an Excel file is .xlsx, a text file is .txt. There's lots of file extensions. For MATLAB, it's a .m file. In your current folder, you should have typed .m. If not, the default is, I believe, a .m for MATLAB. There's also MLX, which is a live script. We are not doing those. Okay, it needs to be a .m. So if you look in your current folder here, notice my file is .m. Okay, so just double check that. And then it says it's your responsibility to make sure your script file works properly. If your script file doesn't work properly, you're only gonna get about 1/3 of the points. Okay, so if it doesn't run without errors, you're only getting 1/3 of the points, regardless of how well your code is. So make sure your script file works properly. Okay. Also, make sure all your variables are named correctly. And then I'll go over the rubrics listed as well. Okay, also, don't use the clear command in your code. Clear deletes everything in your workspace. One of the best practices I mentioned in notes week 1 is to put clear at the top. However, for your homework, don't do that. You won't be able to run your code properly in MATLAB Grader. So just make sure you don't use clear for this, for your projects or for your homeworks here. Okay, and then use the semicolon, we'll talk about that. Utilize MATLAB Grader, I'll show you how to use that. And then upload your scripts to UB Learns, I'll show you where to do that before the deadline. And then here's your problems. So I'm not gonna go through these problems specifically because that would be doing your homework for you. I'm gonna go through some different ones, okay, that look fairly similar. So let me go ahead and transfer over to that. Okay, so here we have some example problems. So here I have, my goal is to write a script file that calculates A, B, C, and D. So we've got these big mathematical expressions, okay? Really the goal of this first problem, similar to your homework, is to translate these equations from mathematical language into programming language. So a couple things to notice. Here I have 11.5 raised to the 2. So I know I need to use the caret in order to do that exponentiation. Here's multiplication. I know for multiplication I need to use my asterisk. For plus, I just use the plus sign. For this square root here, I use the sqrt function. For this one, note it's not square root, it's cubed root. So for this one, I need to use the nth root function. And then minus, I just use minus. Here I use another caret. For division, I use my slash. And then e, remember we can't just type e raised to something. I need to use my exp function. So those are all the things all the functions, all the operations that I need to use just to calculate A alone. Okay, so let me do this in MATLAB. It's a good question. JC cubes. Give me half a second. Oh, nope. Yeah, here we go. Screen share. Let me calculate this in MATLAB. So my variable is named A. So I just say A equals, and then I just start typing everything. So you guys can't see it, but just go along with me. So 11.5 raised to the 2 times, every time you do multiplication, you need to use the asterisk, times 1.342 plus, and then I have square root. So if I'm doing a square root, I type sqrt followed by open close parentheses. This is a math function. This is a function in MATLAB that's already built in that I can use to calculate the square root. So I do square root of 1503 divided by 13. And I'm going to divide that by, now I have another root. It's not square root though, it's the cubed root. So I use the nth root function. So I type nth root, followed by open close parentheses. Once again, nth root is a built-in MATLAB function that I can use that calculates the nth root. And I need to send it 2 pieces of information. The first piece is whatever is under the radical, which looks like this: negative 57 plus 12.35 raised to the 0.7. And then I put a comma. The second piece of information is what is the power on that root, and it's a cubed root. I'll answer you guys' questions in a minute. And then I keep going, then I do minus 12.5 raised to the 7 divided by 4 plus, so here I have e, it's e raised to the negative 3.3. So I can't just do e caret, I'm gonna do exp, open close parentheses. Exp is another function that takes 2.7 something, whatever e is, 2.7 plus odd digits. And I just put in my exponent there, so negative 3.3. There's more than one way to do this. This is, I would say, the most accepted way to do this, but you don't have to use the nth root function. You could say this whole thing raised to the 1/3. You don't have to say exp to negative 3.3. You could say exp1 caret negative 3.3. There's more than one way to calculate these expressions. This is probably the most accepted, most efficient way to do it, but yours might be calculated a little different than maybe your friends. That's fine. Okay, so questions. Is attendance graded in the live streams? No, I have no way to know who you are. So it's completely up to you. It's completely up to you to manage how you are going to and when you are going to take in the information from the class. Would it be fine if you separate the equation into different steps? Absolutely. If you feel like this is too much, it's too long, like I double clicked this because I ran out of space, partially because my text is size 14 for you guys, but partially because it's a really long equation. If you want to break it up into maybe this calculation and then this one and then this one and combine those together, absolutely, it is completely up to you as long as your final answer is stored in the required variable name. Okay, good questions. When raising values to fraction terms, Tidy, you're getting into, so the nice thing about MATLAB is we don't really have to worry too much about losing too much, like there's no such thing as integer division in MATLAB. Every number in MATLAB is treated as a floating point number. Okay, so if you don't understand that, that's completely fine. This is more just background information, but you don't need to worry about loss of precision. You don't need to worry about integer division. You don't need to worry about any of that stuff. Okay, all numbers are treated as if they're floating point numbers, as if they are essentially doubles, if you know anything about data types. Like I said, that is background information. It is more relevant in other languages to be acutely aware of the types of numbers you have, but in MATLAB, we don't have to worry about that. Also, Adil, very good question. So another thing you can do is if your code keeps going and you want to break it up into 2 lines, you could type ... and press enter, and it will continue on to the next line. So this is treated as if it's all written on the same line. You can calculate these exponents really however you want. Like I said, there's more than one way to do it, as long as you end up with the right answer. You could say 12.5 raised to the 7, that whole thing raised to 1/4. Absolutely. Like I said, there's more than one way to do it. You could do nth root, 12.5 raised to the 7, 4. There's more than one way to do it. Okay, so then I can continue and do my next expression. So let's go back to my notes. Once again, write out how I'm going to translate this second mathematical expression into MATLAB code. So I know I've got 136 plus using my nth root here. So I'll point that to that function. Here's another multiplication. Make sure I use the asterisk. Log. So here's a big thing to remember. The log function in MATLAB is natural log. The log function in math is the log 10. Okay, so ln is log, and log is log 10. Okay, so math and MATLAB. Okay, so make sure you guys keep that straight. Joey, I'll answer your question in a minute. And then ln is log. Another thing to point out is a couple of you guys mentioned it, or someone mentioned it on Discord this weekend. So when we have something times 10 raised to the 4th, there's a nice shortcut we can use. We could just replace all of this with E4. Same thing here, replace this with E4. You don't have to. There's more than one way to do a lot of the stuff, but you can do that. Okay, let's go back to MATLAB and start typing this out. So B, that's my variable. B equals 136 plus nth root. Like I said, you guys can't see this, but just trust me. 462. I like to space things out with spaces. You're not required to use spaces in between operations. I tend to use spaces between multiplication and division and subtraction, not always between exponents. It's really up to you. But I'd like to make things clean. So you'll see different variations on that. So that's the top, divided by 759 times 0.029. Notice order of operations matters. So your parentheses, notice all of this was the top and all of this was the bottom. If I didn't group this in the bottom or group this in the top, then this is completely different. It would be 136 plus this calculated times this. So make sure you're using parentheses when you need to group things together. Typically, you're using parentheses when you are grouping things in the top of the fraction and the bottom of the fraction, specifically when you're grouping things in the bottom of the fraction. Or if you're grouping things that you need to multiply together, just make sure you're keeping track of parentheses. A lot of students use too many parentheses. You don't need to be, you're not going to be penalized for too many parentheses. Just be mindful of which ones you need and which ones you're being a little unnecessary about. Okay. And then I do log 10 and whatever was in that, 6.87. And once again, you could type times 10 raised to the 4. That is completely legitimate. You're not going to be penalized for it. You can also type e to the 4. You can also type e to the 4. It's up to you. There's multiple ways to do that. Minus log 3.25 e to the 3. Okay, so I'm gonna go ahead and stop there. There's more in here, but just because I want to get to the second problem as well. So you type all of your required code and you click, you're ready to test it. Frankly, I really recommend that you test it after every line of code that you write for right now, but you write some code and let's go ahead and test it. So I run some code and I get some errors. Notice any errors, any issues with this show up in your command window. Okay. So notice, look, A was calculated correctly. A was not correctly, but A ran without any errors. Okay. A gave me an answer at 91.521. This value showed up in my command window because I didn't have a semicolon at the end. Remember, MATLAB gives us some warnings and some errors that it can immediately find. We can see the bars along here. Here it says terminate statement with semicolon to suppress the output. And I really encourage you guys to put a semicolon at the end of most lines of your code, because even though A showed up in my command window, it also showed up in my workspace. So there's multiple ways that you can figure out what values you have. For B, though, I have an error. So it says not enough input arguments. When it says not enough input arguments, that means that one of your functions that you used, you didn't give it enough information. So if you remember, the nth root function requires two pieces of information. It requires what goes under the radical, and it also requires what the number is on the radical. So for this one, it was a 4. So I forgot to tell it that I'm really calculating the 4th root. So that's fine. You have an error, you go find it, you fix it, and then you think you fixed it, so you go ahead and press run again, and now we have a calculation. Okay. So when it ran this code, it calculated both A and B again, but it only printed out B because A, I put the semicolon in. If I put the semicolon in at B again, I can run it. It will run it. It will still calculate both. And now I can see what those values are. Okay, why didn't you group your fraction variable A? This one here? Okay, so let me close this. I didn't group my function, my fraction in group A here because it was one single expression divided by one, like it doesn't need to be. Like I could put parentheses here, but that's an example of unnecessary parentheses. I don't need to put them around square root because it's just one single number that's automatically grouped by the square root itself. And that's a good question. You can put parentheses there. You're not going to be penalized for it, but that's an example of unnecessary parentheses. Okay, so we have our code. It works. It runs. We know, like, there's no errors when I run it. I can run it a million times. Every time it runs, it prints out what file it was running, and I can see there's no errors. Sarah, by default, use the semicolon. That's really what, unless you want the value to be printed out in the command window, put a semicolon. If you do not put semicolons and you have a lot of code, it's gonna slow down your code significantly. Okay, so now I've got everything typed, I've got everything working. Now I wanna check to see if my code works. So, like I said, you guys should have gone to MATLAB Grader, and you should see homework 1 right now. You should see homework 1, it'll have homework 1, problem 1, homework 1, problem 2. You do them separately. And I've done problem 1. I'm not gonna test it with your homework, it's not gonna work. But here, I'm gonna test it in R1, P1. That's just, you don't see that, that's fine. So what you're gonna do is you're just gonna do copy your code, paste it into the script area of MATLAB Grader, and then you can run your script if you want. It'll print out any errors that you have that you didn't fix in MATLAB, or it's gonna print out your values, whatever, it'll show you whatever is prints out without a semicolon. So there's no output, but there's no errors. If you wanna submit it and check your values, you just click submit. And it'll show you whether or not things are correct. So here it's checking for variable A, it's checking to see if I used all of the appropriate functions, it's checking to see for variable B, variable C, and variable D. Okay. So first things first, you need to make sure your variables are named correctly. So variable A, if I had called it A1, remember, variables are name dependent, A1 is not the same as A. So if I accidentally called my variable A1, it would say, oh, the submission must contain a variable named A. You can go back and you're like, that's right, I didn't name it correctly. So then you would go change it, you would submit it. You can check to see, oh, okay, the value, variable A value was calculated correctly and it's correct. Let's say you typed in something incorrect. Let's say I did 150 instead of 1,503, click submit. It would say variable A has an incorrect value. So you can go through, you can double check, okay, that A expression, something's missing, compare it with what was on the paper, and go back and forth. Change it, submit. If you made changes, make sure that you copy and paste back into MATLAB. Okay, run it one more time, see if it works properly, you're great. Now you have the first problem done. Okay, let's get on to the second problem. So in your homework you have problem 1 and you have problem 2. In problem 1, make sure you're naming your variables P1A, P1B, P1C, P1D with that underscore. It needs to be exactly the same. And MATLAB Grader will tell you whether or not that is correct, whether or not you have the correct variables. Here's that line that states if your code doesn't run, if there's error in your code, you're getting 3 out of the 8 points. So a little more than a third of the points, but make sure your code works. Okay. Yes, unlimited number of times. Thank you, Ronald. I forgot to answer that. Unlimited number of times. You can press submit on MATLAB Grader an infinite number of times. You have until your homework is due. The deadline on MATLAB Grader is listed at like 11 on Wednesday. Ignore that. It shouldn't disappear, I don't think. If it does, let me know. But you can check an unlimited number of times. You have no limits. Okay, so then you have a second script file to write. So go back to MATLAB, new script file. Once again, copy, paste your comments at the top. Oh, someone asked about the comments. For these first couple homeworks, you're really not doing extensive comments because you're really just calculating mathematical expressions. So literally you can just say calculating mathematical expressions. Like, it doesn't need to be complicated. Okay, for the second one, same idea, put comments at the top. This one you're going to be verifying trig identities. Then you save it. So same format, homework 1, problem 2, UBIT name, .m. Now you have 2 files that show up in your current folder that you created that's going to store all of your homework. And then you go ahead and you look at your document. So let's go ahead and look at this document here. Yours is different, but here is a very similar problem. You will be graded on your comments when we get to the programming project. You're not gonna have points taken away for your homeworks. I encourage you guys to have some sense of comments. It'll be really useful for you guys in general. One, it helps us understand what you were trying to do. 2, it helps you understand what you were trying to do. Like I said, you don't need extensive comments, and I'll try to model those comments through the homework solutions and through class as well. So you should get a general idea about what kind of comments you should have. But like I said, for your homeworks, you're not going to be explicitly graded on your comments. You will be for the project. So just get in the habit. It's really not a bad practice to continue. Okay, so there's a problem, something like this in your homework. You're asked to verify trig identities by evaluating the left-hand side and the right-hand side. So here's my left-hand side. Here's my right-hand side. And then we are going to evaluate these for these alpha values. This is a very poorly laid out document. That's fine. And then verify this one for these values. So notice for these ones, obviously we're going to be using those sine functions. So there's 2 sets of sine functions for MATLAB. Or sets of trig functions. There's sine, cosine, tangent, and then your inverses, a sine, etc. There's also sine, sine d, cos d, tan d. So these ones are what you're going to use if your argument is in radians. These ones are what you're going to use if your argument is in degrees. So notice these ones, Notice alpha and beta here are in degrees. So that means I should be using tan d for everything. And I need to calculate both sides independently. So let's go back and start doing this. So here we have left-hand side. I'll call it 1_1. Like I said, your variables, I tell you what they should be in your document. Well, first things first, I need my arguments. Alpha is 45. Use comments to say it's degrees. There we go. Beta, name your variables whatever you want. You could say alpha, you could say beta explicitly. A and B, just fine. It's up to you. Once again, beta is in degrees. Calculate my left-hand side. _1 is going to be tan d of alpha plus beta. That's it. Right-hand side, _1 is going to be tan d of alpha plus tan d of beta. Notice I grouped those together because those are on the top of my fraction. Divided by, grouping together, 1 minus tan d of alpha, tan d of beta. So I did this calculation. I'm gonna go ahead and press run. Notice MATLAB automatically tells me that there's something wrong here. It gives me an underscore, or the squiggly red. It says, hey, something's not right. In the error that shows up in command window, it says invalid expression. Check for missing multiplication operator, missing or unbalanced delimiters, or other syntax error. So here, I forgot my multiplication. Remember, you need to use your asterisk every time you're doing multiplication. I fixed it, press run, and notice if I go into my workspace, those two numbers are pretty much the same. They're pretty much the same. My precision though, whatever is printed out is really only to 4 decimal points. I don't want 4 decimal points, I wanna know exactly what the number is. So there's a couple things I can do. I can take these semicolons off and I can print them out into my command window. Notice, however, in the command window, they're also only out to 4 decimal points. What we can do if we want to find more digits is we can use something called format. Format changes how these numbers would be printed out in the command window. So format short prints out 4 digits past a decimal point. Format long prints out 16 digits past a decimal point. So now if I rerun my code, no semicolon, it prints them out to the command window, and I have lots more digits printed out. So here's an example of where you might want to leave the semicolon off, specifically for the purposes of debugging and testing your code. When you're verified that, okay, that's what I expect, you can put your semicolons back. Another thing that I can do that you'll do for your homework is you can find the difference between these two numbers. So abs_1 equals absolute value of left-hand side minus right-hand side. Now when you run, you can see that the difference between them is something on the scale of 10 to the negative 16, which is pretty small, in my opinion. That's pretty small. Okay, I want to point out one other thing when we do script files, and that's something called the MATLAB search path. So I'm going to do it with respect to this code here. So let me go back to the notes, specifically for week 2. So I talked about this script file stuff in the videos, but I didn't talk about this section here where it mentions that code is executed sequentially. So when we run a script file, we are going to start at the top and go to the bottom, execute one line at a time, top to bottom, and then read those lines more or less left to right. So we already know that comments are ignored. So anything that's beyond the % is ignored. It's not really a line of code. If we go back to MATLAB, notice we've got these lines over here on the side, so it tells me my line number, but also there are these dashes. These dashes indicate where code is. So notice there's nothing for lines 1, 2, 3, 4, even this blank white line. Like that's technically not code. Okay, so here I have 1, 2, 3, 4. I only have 5 lines of code in this document, in this script file, even though there are 12 lines listed out here on the side. Okay, that's the first thing. Back to our notes. So the search path is important in the sense that what computers do is they calculate numbers. They need to work with numbers. They're not working with letters per se. Really, it's the numbers behind the scene. So the search path is essentially a way to figure out what does it mean when we run into something that is not a number. So when a non-numerical, non-operator text is reached, MATLAB is going to go through these steps. First, it's going to check to see if it's a variable. These variables exist in my workspace. So it's going to go to the workspace. It's going to see if that text refers to a variable. If it's a variable, it's going to use the number stored there. Second, if it's not a variable, then it's going to check to see if it's a script file or function file in your current folder. If it's not that, it's going to check to see if it's a script file or function file somewhere else on the search path. And then if it's not any of that, it's going to assume it's a built-in MATLAB function. So let's go through these steps for our code that we have here. Okay, so I'm going to put a little dot there by clicking on that line, and I'm going to click run. What this does is this just opens what's called the debugger and allows me to run the lines one by one. Okay. So before I do that, let me go ahead and clear my workspace and clear my command window. So first things first, I'm going to hit this first line. A equals 45. This A shows up on the left-hand side of my expression, on the left-hand side of my code. So that means it's going to create a variable. It's going to create that container, name it A, and it's going to store some data there. The data it's going to store there is whatever shows up on the right-hand side. So here, very basic, A is going to store a value of 45. And notice that shows up in my workspace. So now I have a variable named A that stores a value of 45. Then it goes to my next line, line 6. B shows up on my left-hand side, so it's going to create a variable, it's going to create a container, name it B, and store whatever shows up on the right. So now I have B that shows up as a value of 60. And then I hit this line of code. So LHS_1 is the name of my variable. It's going to set that aside in memory, it's going to name that LHS1, and then it's going to store some data there. The data it's going to store is whatever shows up on the right-hand side. So on this right-hand side here, I run into this word called tand. So MATLAB is going to go through those steps. It's first going to check to see if it's a variable. Note in my workspace, all I have are A and B. So it's not a variable. So then it's going to go to my current folder. It's going to check to see, is it a script file? It's not a script file in here. It's going to check every other folder that MATLAB has on the search path, which we're not really going to get to. It's not there. So then it's going to go check to see if it's a built-in MATLAB function. tand is a built-in MATLAB function, so it's going to call that function. It's going to send whatever this is, A plus B. Same idea, it runs into the word A. A is not a number, so it's going to check to see, is it a variable? Yep, it's a variable. So it's going to essentially replace this with a value of 45, because that is what is stored in A at this line of code. Plus is an operator, then I have B. Same thing, B is not a number. It's going to check to see first if it's a variable. It is, so it's going to use that number. So essentially it replaces B with 60. Then order of operations, it's going to do 45 plus 60, send that value to my tand function. My tand function is going to run the code inside of it that does the calculation, and then give me back that answer, which is negative 3.7321. All of that for that one line of code. Obviously, MATLAB does it a little faster than I can talk through it. Okay. And then we get to another line of code. So RHS_1, this shows up on the left-hand side. It's going to set aside a variable, name it that, and then it's going to evaluate this expression to store the result. Same idea, tand, it's not a variable, not a script file, it's a built-in MATLAB function. Same idea, A, it's a variable, use that value, replaces it with 45, and keeps going through this idea as it fills in all the numbers and then does the expression. When it does that calculation, I get also a value of negative 3.7321. Then I get to my last line of code. So ABS_1, it does, it sets aside, so that shows up on my left-hand side, so it sets aside that space in memory, nicknames that variable. ABS, once again, it's not a number, so it's going to check to see if it's a variable. It's not. Check to see if it's a script file. It's not. Check to see if it's a built-in MATLAB function. It is. It's just absolute value. And then does its expression. So LHS_1, it's a variable. RHS_1, it's a variable. Subtracts those, takes the absolute value. So that's what happens when you run a script file. Some common mistakes are if you didn't type your variables in the right order. So if I ran this code here, notice when I get to LHS_1, I'm going to run into some problems. So tand, it's not a variable, it's not a script file, it's a built-in MATLAB function. That's fine. But when I get to A is not a variable that's listed in my workspace at this line. It's not a script file, and it's not a built-in MATLAB function. So I'm going to get an error that says unrecognized function or variable A. That means that you didn't create A. You didn't tell MATLAB what A is supposed to be. So make sure you are creating your variables before you use them, which means they need to show up on the left-hand side before they show up on the right-hand side. Okay, some best practices are, like I said, use a semicolon really at the end of most lines of code, unless you're debugging or trying to figure out some stuff. Use format, and you can switch between format, short, would go back. Let me show format. So these 3 lines don't have semicolons, so all 3 are going to be printed out. Format short goes to 4 lines, format, or 4 digits. Format long is 16 digits. If you ever want to go back to the default format, you would just type format. Note the default format puts these blank lines in between everything. If you want to get rid of those, you would type format compact. It's my favorite thing. And you get rid of all of that unnecessary spreading out. Those are really the big things. You can also have everything in scientific notation by saying format short G or long G. No, wrong one. E gives you scientific notation. Format short G is really nice if you have a bunch of different numbers with large differences in their scale. I'll talk more about that in week 5, I think. But if you're debugging, if you're trying to figure out if your numbers are correct, feel free to use format, print things out, take your semicolons off in the command window. For our current homeworks, it really doesn't make that much of a difference if you print things out in the command window, but in the future, you would, it would really slow down your code. So, trigger happy Eli for set A in homework 1. So for set A in homework 1, that's a good question. Set A, these are technically degrees. Assume these ones are degrees. For the second set, assume that you're working with radians. Hold on, hold on. Nope, that's a good question. For the homework, assume everything is in radians. Assume everything is in radians. Okay, specific homework problems. Let me finish up the lecture. I can stick around a tiny bit after lecture, because actually, no, I can't. I have office hours. So hold your questions for a minute. Okay, what was I finishing up? Right. Okay, let's talk about how to submit your homework. So to submit your homework, you have 2 files. So what you're gonna do is you just go to UB Learns, you go to click this link, you browse your local files or however you typically submit your homework, go to wherever they're saved, so documents, EAS 230, and you will submit both of them. Now you can submit them one at a time, you can drag them together. If you want to highlight both of them, you can hit Control. But either way, make sure they are both attached together, and then you just click submit. It will show up as green in the top, not as red, but make sure it shows up as green. You can always go back and check your assignments. So if you go back to here, you click, you will be able to see your submission. You can download your submission, check if it works. You can submit as many times as you want. Just make sure they are both submitted together. Every single time, submit them together. And then you'll be done with your homework. If you are using MATLAB online, you follow pretty much the same process. Only couple things to note about MATLAB online is, so you click new script, let me copy and paste the code in. You would save it Same thing, homework 1, problem 2, EH32, save. It will show up in your MATLAB drive folder. So it's not gonna show up on your desktop, on your file sharing, whatever, your file system on your computer. It's gonna show up in your MATLAB drive where you can create folders, you can right click, create new folders and organize it however you want. Here is where it showed up for me. Keep in mind though, if you make a change, you need to save it manually. I don't know why it does this. It's very annoying. I was using MATLAB Grader this weekend and it's very frustrating. But you have to save it manually before you click run. You can change format here too, all that fun stuff. If you do not save it and you click run, it will tell you, oh, would you like to save this file? Just hit cancel, save it, run, keep moving. To get your files off of MATLAB Grader, you have to click the Home tab, highlight the file, click Download. And then you can submit it to UB Learns. Okay, so we have 1 minute left. Like I said, I do have office hours. I could have swore I told Dr. Ellie they were at 10:15, but that's fine. So a couple questions. So anyway, lecture's over. I'll stick around for like another couple minutes, ask questions. Swiftness, are you giving us more time for Zybooks? If you got your textbook on time, you should have had plenty of time. If you did not get your textbook on time, email me a reason why you should get an extension, and I will do that on a case-by-case basis. But for week 1, you should be able to get it done. For identity 1, do we use set A? And for identity 2, do we use set B? That's a good question. You need to, here we go. You need to do them both. So set A, you should do identity 1 and identity 2. Set B, identity 1 and identity 2. So you need 4 sets of variables, as you can see down here. 1 for identity, the first identity with set A and B, and then another set for identity 2 with set A and set B. Homework questions, you can go over to the Zoom link for office hours. I will be there in a minute. And trigger happy. Okay, homework 2 is wrong in MATLAB. Send help, please. Also, you guys can always, so I will open up Discord. I will open up Discord for office hours as well. So if you want, you can message me in Discord for the next hour as well. Do not copy and paste your code in. If you want to send me your code, email me your code. I can go through it. Just let me know what your name is so that I can associate your Discord or whatever with the email that you sent. Okay, so any final questions before we close this out? Okay, I will see some of you guys in office hours, hopefully. Yeah, this was great. You guys are so much more interactive. I love it. It's awesome.